So today we're covering the final section before we actually have a Unit 4 test. It's section 4.4 notes on parallel and perpendicular lines. And I have other videos that explain this, even with more images and stuff. But let's just do a quick lesson here. Parallel lines. What are parallel lines? A lot of us already know what parallel lines are. What do you think? They're going in the same direction, right? The lines that do not intersect. Okay, so we need to know that parallel lines do not intersect. So if we had let's say a XY plane, and let's say we have a line that crosses at -1, and let's say that it goes up 1 over 2. So there's our line. A parallel line to that one would be another line that's going in the same exact direction that doesn't intersect that first line, right? So let's say it crosses right here at 1, and in order for it to not intersect, it would have to go in the same exact direction, which means it has to be exactly the same steepness, which means that it would have to have the exact same slope. In this case, the slope of rise 1, run 2. So you would rise 1, and you would run 2, and you'd have your dot right here. Okay, so if you were to draw the line through those two red dots, you'd get that green one, which means that this line is parallel to that one. Why are they parallel? Because they're going in the same direction, because they have the same steepness, which means they have the same slope. The slope on the blue one is 1/2. The slope on the green one is also 1/2. So the thing to learn from this little example that I just drew right here is that parallel lines have the same slope. And we already know that. The variable m means slope. So parallel lines have the same slope. Okay. Now, perpendicular lines, those lines for sure intersect. And in geometry, or maybe in the past math classes you've taken, you know that perpendicular lines cross, but they cross perfectly to form a 90-degree angle, right? So if I were to try to draw a perfect line that crosses that green one, actually both of these, it'd be something like this. Well, not exactly. That came out kind of, well, give me 1 second, let me see. Something like this, I guess, yeah. That is kind of like a 90-degree angle right there. I mean, I just sketched it. Obviously, it's not perfect. It's like, it should be a perfect corner if it's perpendicular. So if you look at this yellow line that I drew that was perpendicular to the green and the blue, what kind of slope does it have from left to right? Negative, right? And you know what? To draw it more perfectly, let's say that it crosses at this same red dot, and let's say that it has a point right here at the location 1, 2, right? So from this dot to this dot, what is my slope? You guys said it was negative, but negative what? -1, 2, and over 1. Does that make sense? So even though this is an ugly sketch, if I had perfect graph paper, it'd be a lot nicer. But even though it's an ugly sketch, you could see that the yellow dot, or the yellow line, goes down 2 units over 1 when you find the slope. So the slope of the yellow line is down 2 over 1. So when we talk about perpendicular lines, and when you compare this slope right here of the yellow one that's -2 over 1 and compare it with this green one that's 1 over 2, what do you notice that's different between this slope and that slope? This one is what? Positive or negative? Negative. This one? Positive. Okay? Not only that, this slope, rise over run, besides that it's negative, you have a 2 on top and a 1 on the bottom, and this slope of the green one is have a 1 on the top and a 2 on the bottom. So that is the relationship between the slopes of perpendicular lines, that the sign changes and the fraction flips. The sign changes, the negative changes to positive, and the fraction flips. Okay, and of course we'll get all to this in detail when we get to our printed notes. But how could we put this in nice words that perpendicular lines, that the sign of the slope changes and the fraction flips? That we would say that the slopes are negative reciprocal slopes. So we're going to say have negative reciprocal slopes. Perpendicular lines have negative reciprocal slopes. Okay? And that's the lesson for today in a nutshell. That parallel lines have the same slope, perpendicular lines have negative reciprocal slopes. Okay? What does negative reciprocal slopes actually mean? It means that the sign changes, that's one, or maybe I should just say that's one thing. And another thing is that you flip the fraction. Okay, so the sign changes and you flip the fraction. So the slope negative 2 over 1, if you wanted the perpendicular slope of the line, or the slope of the perpendicular line, you would change it to a positive and flip the fraction, which would become a positive 1/2. Okay? And like I said, that's the entire lesson in a nutshell. Let's actually look at our notes. Here are our notes. And when we look at our notes, this is section 4.4, parallel and perpendicular lines. We also have a previous review of the notes from 4.3. And maybe we'll go back and review 4.3 in a little bit. But right now, you could look and read through the definition of parallel lines. It's exactly what we already talked about. Parallel lines never intersect. They're going in the same direction, which means they have the same slope. Okay? And here are some examples. And you're not even looking at the actual line that's graphed, but you are looking at the equation y equals 2/3 x minus 4, y equals 2/3 x plus 7. I know that these are parallel without even seeing them graphed. I don't have to see if they're going in the same direction because I know if they have the same slope, they're going in the same direction. So what makes this equation parallel to this one? The fact that you have a m of 2/3 there and a m of 2/3 there. They are parallel, right? Number two, they are parallel. The slope is negative 2. And over here, you're probably thinking, wait, that slope's not negative 2. Yeah, but this is not in slope-intercept form. In order for you to see the slope, you either have to have it in slope-intercept form or in point-slope form. You need to be able to see what the m is. Right here, the m is not 2. You need to get y by itself first. How could you change this to become a regular y? You would have to multiply everything by negative 1. In other words, change all the signs. So positive y equals negative 2x minus 4. There's your new equation. And now you could look at the slope, which is negative 2. And as you could see, the slope negative 2, slope negative 2, that's what makes both of these original equations parallel, because they have the same slope. Number 3, you have equations that are in point slope form, which means you could clearly look at where the m value's at. The m value on the first one's 1/2, the m value on the second one's 1/2. That's why they're parallel. If you were to graph them, you would have two lines that never intersect, that go in the same direction, that have the same steepness. If you look at number 4, this one, you could clearly see that the slope is what on number 4? The slope is what? 1/2, right? Could I see the slope on the other one yet? No. It's not 1. Why not? Because it's not in y equals mx plus b. I need an m right here. And the only way you're going to be able to see the m is if it's in point slope form, y minus y1 equals m, parentheses x minus x1. You could see the m. Right here, it's not y equals mx plus b. It's 2y. We don't want a multiplication of 2 in front of the y. So you may have to do some algebraic work before you identify the m. Okay? So let's do that. I need to get rid of the multiplication of 2. How do I do that? By dividing by 2, dividing by 2, dividing by 2, dividing everything by 2, giving me a new equation that reads y equals, there was an invisible 1 in front of the x, so that's really a 1/2 x. And then negative 14 divided by 2, that's negative 7. Here's my slope-intercept form equation, y equals mx plus b. And that's why you could see that the slope is 1/2 and 1/2. That's why they're parallel. Okay? So this is the last part of the section. This is going to be the last part of the test. I like this section because it's pretty easy. All you got to do is make sure that your equation is either in point slope form so you could see the slope, or change it to slope intercept form so you could see the slope. And then you could be like, oh, are they the same? Yes, that means they're parallel. And we also learned this, that perpendicular lines, they intersect each other to form a 90-degree angle. they form perfect corners, right? But more importantly, perpendicular lines have opposite reciprocal m values. What does that mean? You change the sign of the fraction and you flip the fraction. Okay? That's how you tell if they're perpendicular. So these are examples of perpendicular lines. You see this slope right here, it says 2/3. In order for this equation over here to be perpendicular, you have to change the sign to a negative and flip the 2/3 to make it 3/2. That's why these slopes are perpendicular, right? The slope 2/3, you change the sign and flip the fraction. That's why these slopes are perpendicular. So some of the questions on the last part of the test for Unit 4 is going to be as easy as this. I want to tell you, are these lines perpendicular, parallel, or neither? As simple as that. You just got to make sure that you could see the m value, and if they're the same, you say parallel. If they're opposite reciprocal slopes, you say perpendicular, and obviously if it's neither, it's neither. So this is a really easy section. I think we could bump up our grades by understanding this, by practicing it. So this is just more examples of perpendicular lines. This right here, the slope is -2, and technically it would be -2/1. And if I changed my sign to positive and I flipped the fraction, it would become +1/2, and that's exactly what we have here. These two equations are in point slope form. Y minus y1 equals m, parenthesis x minus x1. Y minus y1 equals m, parenthesis x minus x1. Compare that m with that m, a -1/3. If I change it to a positive and flip the fraction, it'll be a +3/1, which is exactly that, +3. That's why these are perpendicular. Get it? Number 4, this slope is 3/2. How do I know? Because it's in point slope form. That's my slope, 3/2. Now, my other slope has to be what in order for it to be perpendicular? My other slope has to be what? Change the sign and flip the fraction. So it should be what? Negative what? 2/3. -2/3. And I don't see a -2/3 here because I can't see my slope yet. Like right here, I could be like, yeah, this right here is my slope. That right there is my m value. Why? Because this is in point slope form. Is this in point slope form? No. Is it in slope intercept form? No. If I want to see the m, I want to get y by itself. So let's get y by itself. This really says -3 times y. I don't want a -3 times in front of my y. I just want the regular y. I want y equals mx plus b. I don't want a -3 times y equals mx plus b, right? So let's get rid of that multiplication of -3 by dividing by -3, dividing by -3, dividing by -3. So my new equation in slope-intercept form is y by itself equals, we always write the negative out in the front, and we have a fraction 2/3 with an x, and then a -12 divided by a -3 is a +4. Here's my new slope-intercept form equation, and now I could actually compare the slope of -2/3 with this slope of +3/2. And yes, this one was positive. If I change it, it becomes negative. The 3/2, if I flip it, it becomes 2/3. So these were all examples of perpendicular lines. So the whole point of these examples that we've been looking at is to be able to tell the difference between parallel or perpendicular lines or neither, right? Again, right here in the notes, it says, the important detail when deciding whether the lines are perpendicular, parallel, or neither is that you must have the equation written in y equals mx plus b form. That way you could see the m right there. Or y minus y1 equals m parenthesis x minus x1 point slope form. Why? Because you could see the m right there. So you need it either in slope intercept or point slope. If it's not in those forms, you got to change it to one of them to be able to see the m, to be able to compare m's. So here are the actual types of questions you're going to see on the last part of the test. I give you two equations, y equals 1/2 x minus 5 and y equals -2x minus 13. Are these parallel, perpendicular, or neither? So yes, these are perpendicular. Why? Because, well, first of all, we could clearly see the slope on both of the equations because they are in y equals mx plus b, y equals mx plus b. So we could see that the m is 1/2 right here, and the m is -2 right here. And technically, that's like a -2/1, right? So is there a change in sign from a positive to a negative? Yes. And do I flip the fraction? Yes. So these are perpendicular. So everybody right next to that first one, you should write perpendicular. Those are perpendicular lines. Okay. Number 2, do I have to do any math before comparing slopes? Yes. Yeah, absolutely. The first equation is not in point slope form. This one is. The second one, I could actually see the slope already, 3/2. But the first one's not in point slope form, and it's not even in slope intercept form. The y's not by itself. I need to get rid of this -3. What do? Yep, divide each one by -3. And remember, there's an invisible 1 right there in front of the x. So what I really have is y equals, and my slope is a negative divided by a negative is a positive, so positive 1/3 with an x. And then negative divided by negative is a positive. 8 divided by 3, you can't do it, so you just leave it. That's ugly, but who cares? Because all we're really doing is comparing slopes. What's my slope here? So once again, are these parallel? No. In order for them to be parallel, they have to be the same slope. 1/3 is not 1/3, so they're not parallel. Are they perpendicular? No, because in order for them to be perpendicular, one has to be positive, one has to be negative, and it has to be the same fraction but flipped. So this is an example of neither. So number 2, you put neither. Neither. They're not. It's not parallel. It's not perpendicular. Okay. So you get the idea, right? And of course, you have to work sometimes to be able to see your slope. In order to see your slope, it has to be either in slope-intercept form, y equals mx plus b, or point slope form, y minus y1 equals m parenthesis x minus x1. If you look at number 3, we have a standard form equation, ax plus by equals c. There is no m in a standard form, so we have to manipulate it. We have to change the way it looks to get it in slope-intercept form to be able to see the m. So on number 4, what should I do first to get the y by itself? Subtract 2x and subtract 2x and rewrite 3y equals negative 2x plus 12. For my final step to get y by itself, I would have to divide by 3, divide by 3, divide by 3, cancels out. We end up with y equals negative 2/3 x plus 4. And why did we do this? So we could see the m value. Y equals mx plus b. We don't really care about the b value on this. We just care about the m value. The m value is negative 2/3. Over here, I need to get this in the slope-intercept form, so I'm going to divide by that 3 to get rid of the multiplication of 3. That'll cancel out. What I do to one side, I do to the other, to every single term. I now have y equals 2/3 x plus the b value, 5 divided by 3. I can't do it, so I leave it like a fraction. All I really care about is the slope, the m value, which in this case is 2/3. So now I could clearly see both of my slopes. This one's negative 2/3, this one's positive 2/3. Are those parallel? No, they're not. In order for it to be parallel, it has to be the same slope. This one's negative 2/3, that one's positive 2/3. They are not the same, they're actually opposite. Are they perpendicular? No, because to be perpendicular, you have to have a sign change from a negative to a positive. That's done. But it has to also flip the fraction. So the other fraction should be 3/2, not the same 2/3. So this is another example of neither, right? So this is neither. Okay? And for the sake of time, this video is getting pretty long. I'm going to leave it at that. If you want to see the other ones, there are other videos that explain it already. I do want to go back and just review a little bit about the previous section 4.3. And right here on these notes, I tell you the exact steps on what to do when they ask you to write an equation given 2 points. Okay? So if they give you 2 points, the only thing you could do is step 1, label your coordinates, x1, y1, the first point, x2, y2, second point, and use the slope formula, and you will be able to find a slope with these 2 points, right? You're going to be able to find a slope. So once you have a slope and a point, you could go for point slope form. That would be step 2, where you take the slope that you just have, plug it in right there where the m's at, and take your first point, x1 and y1, and plug it into those values, x1, y1. And then you have your point slope form equation. And if they ask for point slope form, then you're done. But if they ask you for it in, let's say, slope intercept or standard, of course, you're going to get rid of the parentheses by distributing that number, and then all you have to do to get it in y equals mx plus b, after you distribute that number, is to do the opposite of this number. Where you do to one side, do the other, you'll have y by itself. And then from there, it's really easy to get it in standard form. All you have to do is subtract this x term to this other side, and you'll have it in standard form. Anyway, I wanted to do an example of this real quick. So go ahead and jot this down in your notebook. So, of course, step 1 says to label your coordinates, bless you, x1, y1. That means that's our first point. x2, y2, that's our second point. And then we're going to use the slope formula. It says right here, m equals y2 minus y1 over x2 minus x1. And whenever I use the slope formula, I always recommend for you guys to do this the same. Do the division and the subtractions, and then plug in your y2 value up on the top left, the y1 on the top right. So the y2 value is 7, y1 value is 3, x2 value is 5, x1 value is negative 2, and the minus minus changes to plus plus. Then we do the math. 7 take away 3 is 4, and 5 plus 2 is 7. So we have a slope of 4/7. Okay, let me write that down. M equals 4/7. So if I have a slope and I have some points that I started with to get that slope, then you can move on to step 2 right here and write it in point slope form, which is y minus y1 equals m parentheses x minus x1. I always rewrite it, but with blank spots. Y minus y1, I'm going to leave it a blank spot, equals m, I'm going to leave it a blank spot, parentheses x minus x1, but I leave a blank spot. Okay? Why is that? Because I'm going to take my m value and put it in right there, and I'm going to take my x1 and put it right there, and my y1 and put it right there. Okay? So my y1 value is 3. My m value is 4/7. Let me do that in blue to stay color coordinated. And my x1 value is negative 2. And of course, the minus minus changes to plus plus. So if they would have said, write the point slope form equation, I would be done right here. My answer would be y minus 3 equals 4/7 times x plus 2. But they don't say point slope form, they want standard form. So as of this moment, I have point slope form, and I need to change it to standard. So to be able to change it to standard, we're going to distribute this number to get rid of the parentheses. Now, if I did have a number like 4 or 5 or 2, I would just distribute. But because I have a fraction, and it'll look kind of ugly when I distribute with this fraction, it doesn't work out nicely, I'm going to choose to get rid of the fraction first by multiplying everything by the denominator of that fraction. In this case, the denominator is 7, so I'm going to multiply that fraction by 7, the 3 by 7, and the y by 7. Now, if you're thinking, why didn't he multiply the x by 7 or the 2 by 7? Because whatever I do to this fraction on the outside, it's like if I did it to the inside because of the distributed property that's going to happen. So just multiply the y by 7, the 3 by 7, and the 4/7 by 7, which causes it to eliminate. So the 7 cancels with the 7. So what do I have left? I have a 7y, I have a minus 21 equals, it's no longer 4/7, it's now just a regular 4. And on the inside, we have an x plus 2. And now we could distribute. Not only that, guys, if they did ask for standard form, we should remember that standard form is no fractions, so that's a great thing to do to get rid of the fraction right from the start. So now we're going to distribute that 4. 4 times x, 4x, 4 times 2 is 8. Bring down the equal sign, the minus 21, the 7y. And I am going to move the numbers to the right side and keep my x's and y's on the left side. So I'm going to move that negative 21 to the right side, plus 21, plus 21, and you're going to have a new equation that reads, I'm going to rewrite it over here, 7y equals 4x plus 29, okay? And if I wanted in slope-intercept form, I would divide everything by 7 and I'd be done, but they want standard form, so I need to move the x to the left side. So I'm going to subtract 4x, and I will have negative 4x plus 7y equals 29, and that is my standard form equation. Another way that it could pop up on a multiple choice test would be to change all the signs to a positive 4x, a negative 7y equals a negative 29. but the first one is equally correct. So this was a review of the previous section. There's going to be, this is the most challenging part of the test, I would say, right? And we technically went through all three different forms here. But this is not today's lesson. I probably should have done this at the beginning of the video instead of at this moment. But what is today's section about? Parallel and perpendicular lines. So if we look at this worksheet, 4.4 WSPM, it says write an equation in slope-intercept form. Okay, so we know that we want an equation in y equals mx plus b form of the line that passes through the given point and is parallel. So everybody go to the worksheet, circle parallel, and then write down this. Parallel means same slope. So when they tell you that your line is going to be parallel to the given line, because it says it's parallel to the graph of the given equation. So when they tell you that your line is parallel to the given line, what they're really doing is indirectly giving you the m value, because it's the same exact m value, okay? So they say your line passes through this given point and is parallel to this line. So technically, they are giving you a point, which you could see is -2, 3. It's right here. And they're indirectly giving you a slope. What is my slope of this line that I'm about to draw? It has to be the same exact slope as this one. Why? Because the instructions say that it's going to be parallel. So parallel means the same slope. So the slope is 2. And if they give you a point and a slope, what's the easiest way to write it in? What form is the easiest form to use? Point slope form, which is y minus y1 equals m parentheses x minus x1. And again, when you use this form, please rewrite it with blank spots and then plug in your values. So we're plugging in y1, which is -3. We're plugging in the m value, which we know is parallel to the other one, which is the same exact slope, 2. And then we want the x1 value, which is -2. So of course the negatives have to change to plus. So what we have here is y plus 3 equals 2 parentheses x plus 2. Now, did they ask for an equation in point slope form? If they did, this would be the answer, but they're saying slope intercept. So we need to get y by itself and we need to get rid of the parentheses. So let's get rid of the parentheses first by distributing. That'd be 2 times x is 2x. 2 times 2 is 4. And of course, you have the equal sign and you have the y plus 3 on the left side. Here is y plus 3 on the left side of the equal sign. There it is, y plus 3 on the left side of the equal sign. And now let's get y by itself by subtracting 3 and subtracting 3, giving you y equals 2x plus 1. And there's your equation, y equals 2x plus 1. Now, we did this all with pure algebra. You could have used the visual, like you could have said, well, if my line passes through this point and is parallel to this one, that means it has to have the same slope. So I could have taken this point and gone up 1, 2, and then ran 1 and put a dot there, and this would be my line so far. And I could continue to go up 2 and over 1, put a dot there, and this would be my line so far. And I could continue up 2 over 1 and draw my line, and then I could have said, okay, well, this blue line, what is the equation of this blue line in slope-intercept form? My y-intercept is obviously 1, my b value is 1, and my slope is up 2 over 1 because it's parallel. So you could have done it visually or algebraically. I did it algebraically. You probably could have done it easier visually, but it's good to practice algebraically because down here, that's all they give you, right? They give you a point and they give you an equation, and they're telling you that your line is going to be parallel to this line. So that means that indirectly, they're giving you the slope, and in this case, the slope is 1. After that, you don't need to look at this equation ever again, okay? I apologize for the long video. I do want to just cover a couple more sections. Right here in the middle says determine if they're parallel, perpendicular, or neither. So you first have to make sure that they're all in slope-intercept form or point slope form. This one's in slope-intercept, the slope is 2/3. This one's in slope-intercept, the slope is 3/2. This one's in standard form. You have to change it to slope-intercept by getting y by itself, and then you could compare the slopes, the m values. And if they are the same, if any of them are the same, you could say like, oh, this one and this one are parallel. Or if they're opposite reciprocals, then you could say that they're perpendicular. Or maybe they're just all completely different m values and they're not opposite reciprocal slopes, then you could say neither, right? Down here at the bottom, they say write your slope-intercept form of the equation that passes through the given point and is perpendicular. What does perpendicular mean? Anybody? Opposite. Opposite what? Reciprocal slopes. What does that mean? I'll say change sign. Change sign, flip fraction. So when they tell you to write an equation in slope-intercept form of the line that passes through the given point and is perpendicular to this one, first of all, you don't know what this slope is because it's in standard form, right? So you need to change this to slope-intercept form. That's the first thing to do, to subtract x and subtract x. You're going to have 3y equals negative x plus 6. You'd have to get rid of the multiplication of 3 by dividing by 3, dividing by 3, dividing by 3. Your new equation's y equals negative, there's an invisible 1 right there, negative 1 over 3x plus 2. 6 divided by 3 is 2. So why did I change it to slope-intercept form? So I could clearly see my m value. So now I know that my line has the m value of what? Now remember, the instructions on this part of the worksheet said your line is perpendicular. Yeah, perpendicular to the given line. So the given line has a slope negative 1/3. So our perpendicular slope will be a sign change and the fraction flipped. So that would be a positive 3 over 1. So our slope is positive 3. And now that we have a point, x1, y1, and a slope that we just found because they told us it's perpendicular to the given line, I don't have to look at this equation ever again. I already got the information I needed. Now I could jump to point slope form. Y minus y1 equals m parenthesis x minus x1. Notice I left the blank spots. Y minus y1, that's a negative 6, equals m. M is 3. X minus x1, x1 is negative 1. There's my point slope form equation, but they want it in slope intercept. So change the minus minus to plus plus on both. Rewrite it. Y plus 6 equals 3 parenthesis x plus 1. Distribute the 3. 3 times x is 3x. 3 times 1 is 3. Bring down the equal sign. Bring down the y plus 6. We almost have y by itself. All you have to do is subtract 6 and subtract 6, and you'll have y equals 3x minus 3. So our equation is y equals 3x minus 3. That's in slope-intercept form, and that line is perpendicular to this original standard form line. Why? Because it has an opposite reciprocal slope, and if I were to graph it, they would intersect each other to form perfect 90-degree angles because they're perpendicular. All right, I'm going to stop this video right here.